Hello. Today we are going to learn about number system. This number system is for 9th class students. This entire chapter I divided into 6 parts. So this is one of the very important topic for all 9th class students, both CBSE and state. So today in this class we will discuss about the first part. So number system. So as a 9th class students, you know what is natural numbers, what are natural numbers, and what are whole numbers, and what are integers, and these all things you know. Natural numbers begins with 1. The natural numbers are 1 to 1, 2, 3. These numbers are called as the natural numbers, and the least natural number is 1, and the biggest natural number we cannot define. By the by, whole numbers means if you 0 added 1, 2, 3, so these are called as whole numbers. 0 is the least whole number, and the biggest whole number we cannot define. In the same way, integers are nothing but 0, 1, 2, 3 up to infinite, and minus 1, minus 2, minus 3, and like this. These are called integers. So I don't want to explain more about natural numbers and whole numbers and integers. So in integers we cannot define what is the least integer. By the way, we cannot define what is the maximum integer, I mean biggest integer. So we cannot define both values. So these are the integers. But in 9th class syllabus, it is with rational numbers. So in 8th class only we define what is rational numbers. So rational number means, I will give you the definition. Rational number. Rational number. The definition of a rational number. The number which is in the form of P by Q, where P comma Q are integers, I mean Z, and Q is not equals to 0. So this is the proper definition of a rational number. And in 10th class, another definition, what is the standard definition of a rational number means same definition. You want to write the number which is in the form of P by Q, where P comma Q are integers and Q is not equals to 0. You want to add another one condition, that is P comma Q are the co-primes. So that is the standard definition of a rational number. So here this rational number concept is very interesting, because a number which is in the form of P by Q. So we require to concentrate the formation of a rational number. By the by, students should know all natural numbers are rational numbers, because for example you take some natural numbers 2, 3, 7 like that. We can write these numbers are 3 by 1, 2 by 1 or 7 by 1. So now all natural numbers are in the form of P by Q. Hence all natural numbers are rational numbers, we need to explain. By the way, all whole numbers also, including 0. 0 also a rational number, because 0 we can write it as 0 by 1. This is also in the form of P by Q. Therefore 0 also we can say as rational number, where Q is not equals to 0. In definition of a rational number, there is no condition for P. So Q should not be equals to 0. Therefore 0 also a rational number. By the way, all integers also rational numbers. Minus 1, minus 13, and minus 13 and 5, 6, all we can write as by 1. So all integers also rational numbers. This concept we require to explain all students. First, what is the rational number, how natural numbers are rational numbers, how whole numbers are rational numbers, and how integers are rational numbers, we require to explain the students. So this is the definition of a rational number, and we can say that all natural numbers, all whole numbers, all integers are rational number, and this is the definition of a rational number. Now the first concept here I am going to explain in this class. The first concept is representation of a rational number on the number line. So in 6th class, in 7th class, we already represented integers on the number line. As a 9th class student, we require to know how to represent rational numbers on the number line. So everybody knows that this is my number line, for example. So this is 0 and this is 1, this is 2, this is 3, and this is minus 1, this is minus 2, this is minus 3. So this we can call it as a number line, common number line. So that we can represent integers on the number line, that we know very well. But how to represent rational numbers on the number line? So that is very, very important. For example, I want to represent minus 4 by 5. While representing this rational number on the number line, first you need to think about the fraction. You forget about the symbol of minus, just you concentrate what is the fraction. The fraction is 4 by 5 because it is a proper fraction. It is a proper fraction. 4 by 5 is a proper fraction. Therefore, all proper fractions values are less than 1. The proper fraction value will be less than 1. By that, every student should know that this value will be in between 0 and minus 1. This value will be in between 0 and minus 1 because it is a proper fraction. It is a negative symbol is there. Therefore, it will lies between 0 and minus 1. Now, you take the number line. This is the number line. And you take 0 here. This is 1 and this is minus 1. This is plus 1. Now, I want to represent this minus 4 by 5 on this number line means you need to concentrate on its denominator. The denominator is 5. So, according to the given rational number, we require to make this unit in 5 parts. This unit in 5 parts because the denominator is 5. So, if you want to make it as a 5 parts, just you give 4 strokes, I mean equal strokes like this, 1, 2, 3, 4. Now it become 5 parts. So these parts will be equal. So now this one unit is divided into 5 parts. 1, 2, 3, 4, 5. 5 parts means you don't draw 5 lines. If you draw 4 lines, then this unit will be become into 5 parts. Now it is easy to represent this number on this number line. Minus 4 by 5 I want to represent on it. So this will become, you can write as 0 by 5. 0 we can write as 0 by 5. This become minus 1 by 5. This become minus 2 by 5. This become minus 3 by 5. And this become minus 4 by 5. And this is minus 5 by 5. So minus 5 by 5 again it will be equals to minus 1. Now our required number is minus 4 by 5. Just you indicate that minus 4 by 5 on the number line. So this is the location of minus 4 by 5 on my number line. So like this we can represent a rational number because it is a rational number, negative rational number I have taken. So this rational number I located on my number line. So we will go for the next example also. Here I have taken some different types of examples. So the next example is 2, 3 by 8. 2, 3 by 8. There are 2 methods to represent this rational number on the number line. So by seeing only we can say that this rational number is more than 2. So it will be located after 2. This will be located after 2. 2, 3 by 8 means this rational number value is more than 2. This we should know. So if I draw the number line, so you take this is 0 and you take this is 1 and you take this is 2 and this is 3. So this is 1, this is 2 and this is 3. Now I want to locate 2, 3 by 8 means this rational number will be after 2 only. It will not be in between 0 and 2. It will be in between 2 and 3 because 3 by 8 is a proper fraction. So this value will be less than 1. Therefore, this will be in between 2 and 3. That we require to understand. Then only it is easy to locate on number line. So now I already told you this is already 2. This number will be after 2 means again you want to concentrate on denominator. Just you take somewhat distance between this 2 and 3. So it is 3 for example. So here the denominator is 8 means you want to make this unit after 2 next unit you want to make into 8 parts means you have to give 7 strokes. So this is 1, 2, 3, 4, 5, 6, 7. So now it become 8 parts. Now this is 1 by 8, this is 2 by 8, this is 3 by 8, this is 4 by 8, this is 5 by 8, this is 6 by 8, this is 7 by 8, this is 8 by 8. So 8 by 8 is 1 unit, after 2 it will become 3. So my number is 2, 3 by 8 means it is after 2. Where is 3 by 8? This is 3 by 8. So this is the location of 2, 3 by 8. So that is the location of 2, 3 by 8 on my number line, because it is a positive number. It will be after 0. Here 2, 3 by 8 is there. This rational number will be after 2 on my number line. So this is the location of 2, 3 by 8 on the number line. Here I have taken another example, that is how to locate 8 by 5. So next example is 8 by 5. So by seeing this only you can understand what is this. This is an improper fraction. This is an improper fraction means, so, and positive, you take 0 here and you take 1 and you take 2 here. This is 1 and this is 2. Just I have taken the positive values on my number line because the given number is positive number. You don't want to write negative numbers on my number line. So just I want to represent 8 by 5 on the number line means, first you think it is an improper fraction. This value will be more than 1. You know that this value will be more than 1 means it will not lie between 0 and 1. It will be after 1 on the number line. So by seeing this, you concentrate again on its denominator. 5 is the denominator. Now each unit you have to make into 5 parts. Now 4 strokes. 1, 2, 3, 4. 1, 2, 3, 4. So if I make 4 strokes in each unit, then what happened? Each unit is divided into 5 parts. Now you can write, this is 0 by 5, this is 1 by 5, this is 2 by 5, this is 3 by 5, this is 4 by 5, again this will be 5 by 5, and this becomes 6 by 5, 7 by 5, 8 by 5, 9 by 5, and this becomes 10 by 5. 10 by 5 means you know that value is equals to 2. Now the location of 8 by 5 is, this is the location of 8 by 5 on my number line. So already I told you this 8 by 5 will be after 1 only. It is in between 1 and 2. The location of 8 by 5 we can indicate like this. We can represent 8 by 5 on my number line. So this is one of the easiest method if you practice more and you concentrate on its denominator and whether it is a proper fraction or improper fraction. And its symbol also you want to know. It is positive means it will be after 0. So the positive value, and if it is negative it will be this side of the 0. So here I have taken another example also, that is representation of another number, that is minus 1 5 by 7. This is negative number, and here 5 by 7 is the proper fraction, 1 is there. So this is my number line, this is my 0, you take this is minus 1 and you take minus 2. Why I taken minus means this given rational number is minus number, so it will be minus part of our number line. So here it is more than minus 1, I mean it is crosses the minus 1, it will be in between minus 2 and minus 5. So again here denominator is 7, you want to make 6 strokes here. So this is 1, 2, 3, 4, 5, 6 means it becomes 7 parts. Now you write this is minus 1 by 7, this is minus 2 by 7, this is minus 3 by 7, this is minus 4 by 7, this is minus 5 by 7, this is minus 6 by 7, and minus 7 by 7. So where is my minus 5 by 7 means you want to see this is minus 5 by 7. This number indicates minus 1 5 by 7. Like this we can indicate the given, represent the given rational number on the number line. So this type of questions you will get in your exam. You are representing rational numbers on the number line. So I have taken 4 examples. This is, I think it is very easy to represent these rational numbers on the number line. So we'll go for the next topic. The next topic also very interesting topic. the next topic for the 9th class students is finding the rational numbers between two rational numbers. I already told you, if it is my number line, for example this 1 and this 2. If you make 10 parts, there are 10 rational numbers. If you make 100 parts, there are 100 rational numbers. I mean, there are infinite rational numbers between given two natural numbers. There are infinite rational numbers between given two integers. There are infinite rational numbers between two rational numbers also. So if you take any two rational numbers, we can represent infinite rational numbers in between given two rational numbers. That is the concept of this question. So how to find the rational numbers between given two rational numbers? So that is the concept for 9th class students. So in this standard, there are two methods. The first method is called as the mean method, and the second method we can call it as a direct method. A single step method is there. So here, how to find the rational numbers in between two given, for example, a comma b are two rational numbers. Two rational numbers. Here this is, you say, as rational numbers. Therefore, a plus b by 2 is also a rational number between a comma b. Between a comma b. This is between a comma b. So this formula we can call it as a mean method formula. So how to find a rational number between given two numbers means, if a comma b are any two rational numbers, then the rational number between a and b is a plus b by 2. That is the formula to find a rational number between two given rational numbers. Here I have taken some examples. For example, I want to find the rational number between 5 by 8 and 2 by 5. So this is one of the interesting concept. You want to write a rational number between given two rational number. The first rational number is 5 by 8 and the next rational number is 2 by 5. So here a is equal to 5 by 8 and b is equal to 2 by 5. So the rational number between 5 by 8 and 2 by 5 is, according to the mean method, a plus b by 2. That means a is equal to 5 by 8. This is 5 by 8 plus 2 by 5 by 2. So here you should know addition of factors and every concept you should know. So here the LCM is 40. 8 and 5 LCM is 40. 5 5s are 25 plus 8 2s are 16 by 2. This will become 15 plus 16, 41. 41 by 40 by 2 means this is 41 by 80. So this is the rational number in between 5 by 8 and 2 by 5. So like this, by using a plus b by 2 formula, this method is called as a mean method. By using mean method, we can find the rational number between given two rational number. Therefore, 41 by 80 is the rational number between 5 by 8 and 2 by 5. So like this, we can find the rational numbers between given two rational number by using the mean method. But this is very lengthy in some questions. If the question is not like this, the question is, for example, here I have taken one question, that is, find three rational numbers between 3 by 5 and 2 by 3. Here what we are doing, beta? Here we are finding three rational numbers between given two rational numbers, that is 3 by 5 and 2 by 3. So if you go for the mean method, first you want to find, you take 3 by 5 and 2 by 3. By using mean method, you will get one rational number in between these two. And afterwards you go for the mean method, here also you will get one rational number. And afterwards you go with this, you will get one mean method. So this is very lengthy process to find the rational numbers between these two. If only one number is asking, means it is enough, the mean method is good for that. But if he is asking more than 2 or 3, the mean method also you will get the rational numbers between two given rational numbers. So this, for example, by a plus b by 2 you will get here x, for example. The rational number between these two, that will be x. Afterwards if you will add these two and divide by 2, you will get one another y. and afterwards you add these two and divide by 2, you will get another y. So x, y, z are the rational numbers between given two rational numbers. So like that also we can find, but it is very lengthy process. So easy method I will tell you, that is called as the single step method or direct method also we can call it. So I required three rational numbers between 2 by 3. So in this method what we will do means, first you make the denominators equal. So the LCM of these two is 15. So you can write, if you multiply by 3, 9 by 15, and this become 10 by 15. Now 3 by 5 is converted into 9 by 15, 2 by 3 is converted into 10 by 15. These two are the equal rational numbers only. Just by using the LCM I converted this. So after making the denominators are equal, here the question is asking to find the three rational numbers. So in your mind you want to do 3 plus 1 is equal to 4. So he is asking 3 means you add 1 to 3, then it becomes 4. So now you multiply the both numerator and denominator by 4. What happened you see, 9 into 4 by 15 into 4 and 10 into 4 by 15 into 4. What happened, 9 4s are 36, 50 4s are 60 and 10 4s are 40 and this becomes 60. Now the given rational numbers are converted into 36 by 60 and 40 by 60. Now every student will say the rational numbers between these two, the rational numbers between these two is 37 by 60, 38 by 60 and 39 by 60. So these are the three rational numbers between given two rational numbers. By using this direct method, we can find how many rational numbers you require. How many rational numbers you require, you can find by this method. While doing this method, first you need to concentrate on the denominators. First, if the denominators are equal, you can apply that rule. If you want to 5 rational numbers means 5 plus 1, 6, you multiply with 6. If you want 10 rational numbers means 10 plus 1 with 11 you multiply. If the denominators are not equal, first by using LCM you make them as denominators are same. Then afterwards you apply this rule. Then you will get how many rational numbers you require according to the given number, according to the given question. So this is the very important concept. On the basis of this, you will get a question in your exam, finding rational numbers given between given two rational numbers. The first method is mean method. The second method is single step method or direct method. By using this method, we can find more than two rational numbers between given two rational numbers. Next, the next topic is very interesting topic for 9th class students. The decimal representation of a rational number. First we require to know what is decimal. So there are three types of decimals, but I am going to write here 0.32 and 0.323232 ... 0.32456013578. So this you learn in 8th class only. There are three types of decimals. The first decimal, it is terminated after two decimal places, so we can call it as a terminating decimal. This we can call it as a terminating decimal. And the second one, it is not at all terminated, it is continuing, but one thing you need to observe, 3232 is repeating. Such a type of decimals we can call it as NTR decimals. NTR decimal means non-terminating repeating decimals. Non-terminating repeating decimals. So it is non-terminated, but some decimals are repeated. So these type of decimals are called as a non-terminating repeating decimals. So, but in the third case, it is also not terminated and it is also not repeated. So these type of decimals we can call it as non-terminating, non-repeating decimals. So these decimals, we need to concentrate these type of decimals. Why? I told you one important thing. These two decimals we can convert in the form of P by Q, but these type of decimals it is not possible to convert in P by Q. It is not possible to convert in P by Q. So afterwards we will discuss about these type of decimals, but you concentrate on these two. So this is a terminating decimal and this is non-terminating repeating decimal. These two type of decimals we can convert in the form of P by Q. Therefore we can say that these two types of decimals we can call it as rational numbers. Here I wrote rational numbers. So because terminating decimals are rational numbers and repeating decimals also rational number. So what is my next concept is decimal representation of a rational number. Decimal representation of a rational number means, now I am going to tell you one interesting thing. You take any rational number. For example, here I have taken 3 1 by 8 and 2 by 11. So here two rational numbers I have taken. That is, the first rational number is 3 1 by 8 and the second one is 2 by 11. So if I convert these rational numbers into decimal means, either those decimals are terminating decimals or repeating decimals. There is no chance for non-repeating, non-terminating decimals, because I told you only the first two types of decimals are called as the rational numbers, because we can convert those decimals in the form of P by Q. So if I convert these two questions into decimal, either they are terminating decimals or either they are repeating decimal. For example, if you take 3 1 by 8, 24 plus 1, this will be 25 by 8 and this is 2 by 11. This means 25 is divided by 8. 8 3s are 24 and this become 1. So if you put point, you will get 0, 8 1s are 8 and you will get here 2. Again point is there, 8 2s are 16. Again you will get 4 and 4 5. So this is 40 and 0. So this is a terminating decimal. I mean it is terminated after 3 places of the decimal. So it is converted into 3.125. So the decimal expansion of this one is 3.125. So it is become a terminating decimal. For example, if you take 2 by 11, what happened? You see, you divide with 2, 11. So this is 11, 0 point, this will become 20 and 11 ones are 11 and this will become 9. 0 is there, 11 8s are 88 and become 2, 20. Again 11 ones are 11. It become again 9, 0 and 11 8s are 88 and again you will get 2, 0 and 11 ones are 11. So it will continue. So you will get this is 0.18181818. This is continuing. Means the decimal representation of 2 by 11 is a repeating decimal. So by these two examples we can say that the decimal expansion of any rational number, either terminating decimal or repeating decimal, there is no chance for non-terminating, non-repeating decimal. So this is the decimal expansion of a rational number. So if you want to find the decimal expansion means, here you want to divide with the denominator, then it will be converted into decimal form. But here one interesting question is there. Convert the given rational numbers into decimal without actual division. I told you, if you want to convert the rational numbers into decimal means you want to divide with the denominator. But here my question is, without actual division, write each of the following decimals in the form of decimals. So here my question is 5 by 8. One question is 5 by 8. So another question is 7 by 25. And another question is, I will take somewhat big number, by 620. You want to convert these rational numbers into decimal. So here my condition is without actual division. Without actual division you want to convert these rational numbers into decimals. So there is a rule. There is a rule. What is that rule means? The prime factorization of the denominator. The prime factorization of the denominator is having only factors 2 and 5. Only having the 2 and 5. The prime factorizations of a denominator having prime factors 2 and 5. 2 and 5 means here you want to concentrate. Sometimes it is having only 2 as the prime factor. Sometimes it is having only 5 as the prime factor. Sometimes it is having 2 and 5 prime factors. Then the fraction it become a terminating decimal. The prime factorization of the denominator is having only 2 and 5 prime factors. Then the rational number, if you convert into decimal, it become a terminating decimal. On that rule, here I wrote, that rule I wrote here. Rule is prime factorization of q is 2 and 5. the prime factorization of q means the denominator is only having 2 and 5 as the prime factors, then it will be converted into terminating decimal. How? You see, Nana, this is 5 by 8, then it will be written as 5, 8. If you go for the prime factorization of 8 is 2 to the power of 3. What I am doing here, 5 by 2 to the power of 3. I am multiplying the both numerator and denominator with 5 to the power of 3 and 5 to the power of 3. So 5 into 5 to the power of 3 is 125. This is 2 to the power of 3 and 5 to the power of 3. A to the power of x into b to the power of x is equal to ab whole to the power of x. Both are having the same power. Then 2 5s are 10, 10 cube. If you multiply 5 into 125, 5 5s are 25. 2 5 2s are 10, 12, 1. This becomes 625 and this is 1000. Now 3 zeros are there. The decimal will move back 3 decimals. This will become 0.625. Now I converted 5 by 8 into decimal without actual division. So it will be possible when the denominator is having the prime factors as 2 and 5, it will be possible. The prime factors are 8 is only 2, then I multiply it with 5 cube, then it will become that the denominator is becomes 1000, then it is easy to write. For example, you go for the second example, this is 7 by 25, this is 7 by 5 square and 7 by 5 square is there, you multiply with 2 square, so 7 into 4, 5 square into 2 square is 10 square, 7 4s are 28 by 100, then 2 zeros are there, it will become 0.28. Now converted the given rational number into decimal without actual division. These type of questions will be appear in your exam. So the condition he will give you without actual division, write the decimal form of the given rational numbers. So you want to concentrate on its denominator. Next one, if you see, this is somewhat big number, 625. So 231, the prime factorization of 625, it will become 5 to the power of 4. And this will be 231 into 2 to the power of 4. And this is 5 to the power of 4 into 2 to the power of 4. Just I multiplied with 2 to the power of 4. So 231 into 2 to the power of 4 means 2, 4, 8, 16. And this becomes 10 to the power of 4. So 231 into 16 by this is 4 zeros you have to write. 16 ones are 16, 1, 16 threes are 48, 49, 4, 16 twos are 32, 36 by 4 zeros. It will become, the 4 zeros will move back, this will become 0.3696. So without actual division, I converted the given rational numbers in their decimal form. So it will be easy when the denominator is, the prime factorization of the denominator is in the form of 2 to the power of something into 5 to the power of something, then we can write the decimal form of the given rational numbers without actual division. So this is one of the interesting concept is there for your 9th class students. And another important concept is there, that is how to write the rational form of a decimal. How to write the rational form of a given decimal. For example, here 3.2 is there. 3.2 means you can write this is 32 by 10. If you simplify, this will become 16 by 5. So 16 by 5 is the rational form of given 3.2. So if it is given like this, it is easy to, for example, 12.5 is there. You can write 125 by 10. If you make 5 table, 2s are 5s are, this become 25 by 2. If the decimals are like this, it is easy to convert the decimals in the form of p by q. Here my concept is how to convert the repeating decimals in the form of p by q. This is very important question. You will get one question in your annual exam, to conversion of a repeated decimals in the form of p by q. So how to convert? It is an algebraic process. So I will tell you that process how to convert this repeating decimals. For example, here 0.51 bar. So while solving these questions, you require to do concentrate. On how many decimals the bar is there means on 2 decimals the bar is there means 515151 it is repeating. Now I want to convert this into the P by Q. So let you say x is equal to 0.51 bar. Now therefore x is equal to this will become 0.515151 dot. So here 2 decimals are repeating, you write 100x. So I am multiplying with 100 to the LHS. You want to multiply 100 with the RHS. If I multiply this decimal with 100, the decimal will move 2 points like this. Then it will be 51.5151 dot. So according to the assumption, I mean according to our value, x is equal to what? 0.515151. You subtract these two equations, then it will be 100x minus x, this become 99x, that is equal to 0, 0, 0, 0, 0, 0. 51 minus 0 is 51. Therefore x is equal to 51 by 99. Actually x is equal to my number, that is 0.51 bar is equal to I got 51 by 99. So this is the rational form of the given repeating decimal. So this question is very easy, but sometimes it will be somewhat complicated how to find those numbers. I think you understood. First you take this exercise as a given number, then afterwards how many decimals are repeated. So you take 100x and x and you subtract it and you will get the value of x in the form of P by Q. Sometimes this should be, sometimes you want to simplify it, but here it is not possible. You leave that, oh it is possible, I am sorry, with free table it will go. So 3 1s are 3 and 3 7s are 3 3s are 3 3s. I am sorry, this is 17 by 33. So 0.51 bar is equal to 17 by 33. So this is the standard rational number of 0.5 bar. So like this you want to convert the given decimals into P by Q form. So I will take the another example. That is 1.323 bar. 1.323 bar. Here the question is the bar is on 2 3. So same method, let x is equal to, you say as 1.323 bar means the 2 3 2 3 2 3 is repeating. Now you take first 1 2 3 1000x is equal, the decimal will move 3 decimals means 1323.232323 bar. Next you take 10x. What happened? The decimal will move only 1 point, that is 13.232323 and you subtract 1000x minus 10x is 990x is equal, these are all zeros, 0 1 0 1 3 1. So 990x is equal to 1310. X is equal to 1310 by 990. So 0 0 cancel. X is equal to 131 by 99. So according to my question, x is equal to 1.323 bar, that is equal to 131 by 99. So this is one of the easiest method to convert the given repeated decimals into the form of P by Q. If you practice more questions, I mean if you practice more questions on this base, you will get some perfection. So here I have given some question. Another question is also given, that is 0.52. The bar is only on 2. You practice this question. So in this session, we will learn what is rational number and how to represent those rational numbers on the number line, and finding the rational number between two given rational numbers. In that concept we learn two methods. The first method is mean method. This mean method is used to write a rational number between a single rational number between two rational numbers. But the direct method or single step method is used to write more than two rational numbers between given two rational numbers. In the third concept, how to write the decimal form of a rational number. Here also I explained about the decimals, the 3 types of decimals. Only 2 types of decimals we require to know, that is terminating decimal and repeating decimal, because the 2 decimals are called as the rational numbers. So how to represent the rational numbers in the decimal form I explained, and without actual division. Here I explained one rule. This rule is very important, that is the prime factorization of the denominator of a rational number. So by using that rule, we converted given rational numbers into decimal without actual division. And the last one, how to express the repeated decimals in the form of P by Q. So in this session, we learn all these points. So in the next class, this entire chapter I divide into 6 parts. So this is the first part. The next part is about the irrational numbers. Thank you.